Let's talk to Donald, he, him from Louisiana. Donald, you are live on AXP. It sounds like you want to talk about a possible interpretation of God that's different than a lot of people have come up with. What's your idea, Donald?
Yes. I'm trying to blend basically ideas from many philosophers, mainly Berkeley, Plato, Aristotle, and Jung and Schopenhauer, to basically, okay, some of the people I said were atheists, or how you would categorize them for their time. But I think, for example, Schopenhauer's ideas of like will and representation can't. All you have to do is say that the will in his will and representation is bound to some kind of cosmic consciousness that can that dictates like the perfect forms of things, and you can use ideas like the unactualized actualizer to try to explain its origin. But I mean, there, of course, with this conception, there's a limit to like how much you can know about it. But do you have any questions like right now, or because I have like a list of like axioms?
Yeah, so it sounds like there's kind of this. You're taking the perspective of a few different philosophers to try to synthesize a different interpretation of like God. I'm just questioning: is this for you? Is this more of a like philosophical exercise, or do you believe that this impacts your worldview in any way? Like, do you think that you're taking these ideas and applying them to some kind of use, or is this more of a like mental exercise for you?
Well, I'd say I'd lead more to a mental exercise, but
Gotcha.
but I mean, I think it's a possible interpretation. I doubt it, because a lot of the ideas based off of it is like I'm heavily relying on Berkeley and his idea of that. Oh, because all of our senses aren't perfect and stuff, that the thing that's linking all of reality together is like the mind of God. And I'm using the idea of the unactualized actualizer, like from Aristotle, which a lot of his things derive from that, like goes against our ideas of physics, like inertia and stuff. So, and I think consciousness is emergent from material things, and I don't think what people describe as consciousness and the idea of a soul, it doesn't make sense to me. So yeah, I lean way more atheist, but I'm not. We just know so little about the universe, and when you get sometimes when I look at things like quantum entanglement or how well math works, and it leaves room for doubt, and it does affect my worldview somewhat. I see this as a possibility. I don't see it as a likely one, but it's high enough to consider.
Gotcha. Real quick, I do want to let Scott get in here too, but I know there are a lot of people in the audience who don't necessarily recognize some of these philosophers or their specific viewpoints. Could you try to articulate your position as if you're talking to like a classroom of students, like who may not have heard this before?
Okay. Yeah. First, I would say there is this idea from Aristotle of everything has a cause and effect, but to not have an infinite regress of causes, he thinks there should be some unactualized actualizer, and then other people have like Aquinas and stuff have used that to like try to explain the Christian God, and then there's like Plato's ideas of forms, and like that reality is like, if he does an analogy, if you're in a cave and there's like shadows from the outside and you can only see the shadows, you don't know the forms outside, and he like points to things like geometry, like he thinks there's a real perfect triangle out in some realm of forms and stuff. And then later philosophers like took his idea and said from this forms there should be the one, and then later it got reinterpreted by like St. Augustine to that one to be the Christian God. And he makes an argument that since math and numbers all work so well and stuff, is that the thing linking all the numbers needs to be conscious. So consciousness is a higher plane than physical reality. And then you have idealists like Berkeley. Like it's kind of long. There's like a whole tradition between the rationalists and the empiricists, and talking about how well you can rely on your senses versus how well you can rely on induction and senses versus how well you can rely on deduction that is built off of axioms. And Berkeley basically his conclusion was our senses aren't truly real, and for everything to not to be working so well that we are that there is a great awareness that is the mind of God. Berkeley's more complicated than this. I have to do a shortened version, but
yeah.
And then there's Jung and the collective unconscious, which can be linked to Plato's forms and ideas of archetypes and stuff. And if you want to know about that, I think many people have heard of Jordan Peterson. He summarizes Jung quite a bit.
Yeah, I think we got a good idea. Yeah, I think we've got a good idea for where your position is now. I think this is a great one for Scott to get in on, especially if you want to talk about geometry and math.
Sure. Yeah, Donald, just a quick question here before we dive into that. Are you, when you talk about a possible interpretation of God, are you referring to just like looking and seeing something else in the world that doesn't match up with what other people normally refer to when they say God? Or are you saying God is really different, or are you making an argument for a God, like a being? Are you still talking about a theistic God, a being with a consciousness and intentions and that kind of thing? Is that what you're talking about? Or are you really?
Yeah. I didn't mean to cut you off.
No, that's fine. Please continue with your thought.
Okay, I don't have a fixed definition. I first was thinking about this and thinking about these different interpretations of God and the different philosophers. But in this, I'm basically arguing for a omnipresent, very extremely powerful consciousness that is beyond the limitations of time and space, and created time and space by being an unactualized actualizer, and things like archetypes of other gods and other religions and forms are like Jungian archetypes derived from this grand.
Sorry to interrupt here, Donald. I'm not sure. I don't feel like you're addressing my question. It sounded to me like at first you were saying you were kind of supporting a more traditional view of God, and then you kind of went back to, well, maybe it has to do with, Platonism or something along those lines. Is that what you're? Are you talking about a God, or are you just saying that, well, maybe we could mean some other things if we said the word God? Is that what you're trying to get at?
Okay, okay. I'm not strictly going with exactly the Christian God, but I am saying one conscious being beyond
Okay.
space and time that has that makes everything possible by its will and its observation of things. But
Okay. All right. I think that's enough that we can start here. I wanted to address one thing that you brought up. You said something about um, that about math works or something like that. Could you expand on that? And I'm math literate, so please feel free to get as much into the details there as you'd like.
okay, well, if you just look at some laws like the Pythagorean theorem and geometric proofs, and how they like, you can come to those from pretty from almost from just a few axioms and deductions, but they work in the world, and you can see forms of them all of the time, and the fact that everything's obeying formula and equations, it's the amount of order in it.
Okay.
It just is.
So you're saying, are you describing the system of math as like some kind of determining the way things are, and forcing things to be a particular way, being prescriptive? Is that what you're saying? Is that math kind of forces things to work out a certain way? And if how could that possibly be unless there's some kind of creator God? Is that what you're implying? Because I don't know if I would agree that math is necessarily prescriptive. I mean, if we think about how we developed math, I mean, there's a couple different ways of looking at what math is. Okay, as humanity, we've invented this mathematical language to describe descriptions of the universe. We started out, our earliest math was counting things, and we counted on our fingers, and we counted with stones and so forth, and we developed from there. And so my question to you then would be, how can you jump to the conclusion that math is prescriptive rather than merely descriptive? Because from all evidence from the history of mathematics and science, for that matter, is that we learn things about the universe by observing, and then we draw conclusions for what we see. So what it's really not the case that, or at least we can't make the case, or rather, I've never seen the case successfully made, that there's anything outside of the universe that's kind of forcing the universe to be this way, not forcing gravity to work a particular way, not forcing the Pythagorean theorem to work a particular way. We see things the way we see the way the universe is. We see that there's patterns. We describe those patterns. Then we shouldn't be surprised that our descriptions happen to match the universe, right? Since if we view mathematics and science as a description of the universe, of course it should match. It's derived from the universe. And so when if you say something like, how is it that math works? Well, because we saw what was there, we described it, and so that's what we're doing, is we're referencing that description. Does that make any sense, Donald?
Yes, and I understand what you're getting at, but some of the math, you can come to it without going out and like using empiricism. You can come to it from a few axioms and pure deduction, and then that is matching so well. It's one thing if you go,
Yeah, Donald.
you just run and
like exactly what Scott is saying though, like math and science are branches from philosophy. Like all of this stemmed like from the same place. And yeah, you're going to see those patterns in reality. Like you keep going back to the Pythagorean theorem. Like what is the context and the usage for the Pythagorean theorem? Do you remember from school?
I'm pretty sure it was for building pyramids and
Like it's for right triangles, right? Like you use the Pythagorean theorem for right triangles. There's a set context in which that equation works. You can't apply that to some other type of shape because that model was meant to describe right triangles. So yeah, if you go out in the world and you find another right triangle, you're gonna see application of the Pythagorean theorem. And there's a lot of different mathematical equations that sure are pretty accurate most of the time because we're using them within the context that they were designed for. And I'm saying design because humans made mathematics to describe the world around them. Like, but you take the math outside of that context and it doesn't work anymore, or it changes. For example, in physics, you have these coefficients that you're going to use to describe gravity. 9.81 is what we use for the gravitational pull, like here on Earth, or the acceleration due to gravity on Earth. That number is not going to be the same in a place with a different acceleration due to gravity. But it's not because there's some supernatural reason for that equation to work that way. It's because the parameters, the variables, are all applicable to that specific context and setting. So yeah, I think you need to flip it. Go ahead.
Okay. 9.881. Yeah, I agree. The gravitational constant of Earth. I mean, it's not technically constant since you can like have shifts in like different places of water.
Yeah, it's the coefficient for the acceleration due to gravity
of the Earth. Yeah.
But coefficients, yeah, that you can only basically get by directly by going out and using your senses and doing empiricism and experiment. Yeah, that I'm not saying is from some supernatural source, but going back to the Pythagorean theorem, yes, I didn't get what you were saying. I know it's right triangles, but if you take the ideas of it, of the adjacent, the hypotenuse, and the opposite, and you take those ideas from it, and then you change it for other than right triangles, you get things like the trigonometry rules of sine, cosine, tangent, and
those are all. It's all just solving, Donald. Those are all just solving for different variables. It's just using critical thinking to derive a model to find out a missing variable in the equation. Like if all of these other numbers are a certain, if we assign certain numbers to each different side length and angle, we're going to be able to find out the other angle that we're missing because they all have to equal a certain amount. So that's just finding like variables that you're missing. Like that's all that this is. There's nothing like supernatural or super meaningful beyond that about that.
Let me add something. Sorry, Donald. Let me add something to what Dr. Ben said there before you go on. So like you mentioned, the Pythagorean theorem turns out to be a subset of a larger law called the law of cosines, and also. They did use the Pythagorean theorem, or at least a variation of it, when building the pyramids, or at least it's proposed, it's hypothesized that they did. I don't know if they ever actually have any evidence of that, but it seems like they would be able to. They had the technology and the knowledge to be able to use that. They can set up a right triangle, they can measure the lengths of the sides, and that helps them to determine that the angle between those sides is in fact a right angle. But let me give you an example here and tell me what you think of this. Let's say that I went out and I looked at a bunch of apples and I saw that they were all red. Okay, I have dozens and dozens and dozens of apples in front of me, and I look at them and they're all red. Okay, and so I say, hey, apples are red. Let's make that a law. That's a law. That's something I have observed in nature. Apples are red. So then what I do is I go down the street and somebody tells me they have an apple, and I say, you know what? I bet you that apple's red. And they pull it out and they say, you're right. That's amazing. That law of the universe made this apple red. There must be something weird happening here. There must be some sort of supernatural creator that did this. But no, what really happened was we saw a pattern. We named that pattern. In this case, I just said, the apples are all red. And then we went, and then should we be surprised that we go out into the world and notice that kind of thing happens? It's not, I haven't justified belief that there's anything prescriptive about this quote unquote law of red apples that I've noticed and that I named. There's no reason for me to think that that's prescriptive, that there's anything making the apples red. What happened was I noticed a pattern and I gave that pattern a name. That's what we're talking about here. And so when you talk about how mathematics works, yeah, no kidding, it works. We went out, we looked at the world, we described patterns that we saw, and then we shouldn't be surprised at all when the patterns that we find happen to match that description, because the description was based on what we observed. And that's how science works. That's the number one step in the scientific method, or I suppose depending on how you set it up, but making observations comes before drawing your conclusions. And so scientific conclusions are not prescriptive conclusions, they're descriptive conclusions by definition. And so at the most, what we can say after going through this entire process is that we've summarized a description of what we see. Now, if we do that, I don't think we should be surprised then when we go out and find out that the universe actually matches that description. Does that make sense, Donald? Okay. What do you think about that?
I think there's a false equivalency here with all the red. When you were saying that, I thought you were about to do the apple's green and the black swan fallacy, but the apples, okay, again, and that's knowledge. Okay, that's synthetic a posteriori knowledge that you got by observing and doing induction in your
Yep.
senses to find a pattern. But
okay.
but a lot of math can either be true, is true by definition, but some of it, so that's not surprising, the true by definition, but some of it, some of the laws of triangles and stuff, it can be synthetic, but you can come to it a priori without your senses. That's the class of math and knowledge that I'm saying is distinct here, because you don't need your sense is to come in and find it. Your thing works for the knowledge where it's like a constant, or apples are red. It's synthetic a posteriori knowledge, but knowledge that is synthetic that you can come to without using your senses, without empiricism, and it's still come to be true. This is the part.
It's possible, but it's a lot harder to demonstrate that it is true. Right? How are and there's
worldview.
I would go further and say that you are not, in fact, doing completely a posteriori observation there. I think that let me ask you this then. Can you name one mathematical fact that is not based on observation of the universe, and that is not based on other observation? We notice patterns, right? One of the patterns that we notice is that if I have this set of facts, I can manipulate those set of facts to generate other sets of facts. That's one of the patterns that we've discovered mathematically in nature, is that if we know certain facts exist, we can use those facts to generate new facts. That's one of the patterns that we've observed. That's not something that we created up out of nothing. We noticed that happens. If I have 2 stones here and 2 stones here, if I put them together into one big pile, they will make 4 stones. We generalize that to beyond stones, and we have our foundations for mathematics there. So can you name me one mathematical fact that's either not based on observation or is not based on conclusions we've drawn from other observations?
Okay. That's okay. I would say axioms, but most axioms came from them observing the world and then coming up with them. But you could come to the axioms without doing that, like things like Euclid's 5 postulates, and then and things in set theory. But then you get into, well, some axioms can be false, and like the 5th postulate, and then you get into questions of the axiom of choice and the axiom of determinacy. But my point is, okay, yes, most of the axioms and stuff, they were just formalizing their intuition, which was built out after a lifetime of observing things in the world. But you can come to them without that. But it's
how do you do that?
Separate these things.
How do you come to them without that?
Okay. First, you would have. You're imagining a brain in a vat that doesn't have any senses.
Let me pause you for a second here. Let me pause you. I want to put a finer point on my question. How can you come to those conclusions without relying on either previously observed facts or previously observed patterns that can be used to generate new facts? In other words, we're not going to use any foundational axioms or any other assumptions, any other things that we've observed in nature. And we're not going to apply any patterns of reasoning, patterns of thinking that we've also observed in nature. So how can you come to those conclusions without using previously observed math knowledge and previously observed math processes or methodology?
Okay, well, the methodology and stuff is derived from logic, and logic, like I think if we were to take a human mind, it just inherits patterns and structures in its brain to
from where
logically.
Where does it inherit those patterns from?
Okay, well, are we saying what I actually believe, or what, or from the argument that I'm making here?
Well, if those are two different things, I'm curious as to why you would be making that argument. But if you're just making, I mean, we can examine arguments on their own merit. Let's focus on the argument. On how does what you're saying support your conclusion?
Okay. What I would say is there is some kind of consciousness that would be creating the forms. And
are you conjecturing that, or do you have reason to believe that?
Okay, but my reasoning stem from the ideas of Plato's forms, and also things in quantum mechanics where like Bell's inequality and information seems to be able to be non-local. But
okay, so that would be a conclusion. So I want to know, how do we get to that conclusion? You said you can come to that conclusion without relying any previous observation. And I'm gonna shut up here a little bit. I want to hear a little bit from you, and then we'll see what if Dr. Ben wants to chime in on this.
Okay, well, how are we going to define an observation? Because I was going to do a brain in a vat, but it's observing its own consciousness, and it would have to then determine, okay, the idea of existence exists, and I can take the leap that thoughts exist, and I think therefore I am. But are you going to count that as an observation, even when it is just observing itself and it has no senses?
I'm asking you, how can we come to the conclusion that a mathematical truth is true without, now you're saying that we can derive that absence of observation a priori, right? And so what I'm asking you is, first of all, can you name one of those mathematical truths? And then can you show me how we can come to that conclusion without relying on previous observation, which includes the observation of certain patterns of truth, which includes logic, by the way.
Well, okay. I don't think you're able to do it without making any observations, but I'm making a distinction between observations from your senses versus completely internal observation of thought and logic. Those are two, because I was saying that the consciousness is beyond the physical realm, and so a consciousness that isn't bound by space-time or matter and energy, that would be able to observe itself without these things. But,
so you're conjecturing.
So I'm conjecturing, yeah.
Okay. All right, Ben, do you have, I've been talking here. I'm so excited we got a math question while I'm on. So I'm going all over this. So I just want to make sure I give Ben a chance to talk about this too. Ben, who also is math literate as well, I should point out.
Yeah, I'm having fun watching you two go at this. I feel like we do have some other callers in the queue though. So if we want to, like, we can talk for a little bit longer, but then if we can start kind of getting to the end, and then we can continue this another time as well. And Donald, I'm going to say this, definitely call another time to talk heathen, and we can continue this conversation, because Scott is over there quite a bit, and I'm sure we'd love to have continued conversation on this with you. So.
Okay, so when to call? Just next weekend, or?
If you look on the YouTube, they usually post ahead of time, like the next 7 shows or next 6 shows or whatever, when who's going to be on when. And so, but I want, while you're doing that, I want you to bring your A game when you come. So I want to give you a little bit of homework here. It's my nature. I'm a teacher. So I'll give you a little bit of homework here, and I want you to think about that. I want you to think about the distinction between nature and, as a subset of that, mathematics and logic. How can we show that they are prescriptive? How can we show that they are prescriptive? The reasoning that we use, in fact, I would go out on a limb and say, you actually went through this process of learning this, learning how to do mathematical reasoning to some extent or another. And you start out by, when you're a little kid and you're in kindergarten and you're counting blocks or you're counting apples or whatever. And so you start with the basics based on observation. When you first learn how to add, they have little piles of apples and you can push them together and do things like that. And so you start with observation, but the reasoning itself is also part of an observation. We notice that reasoning in our universe produces certain types of results. When we do this type of action called adding, we get this particular type of result. The same thing applies for reasoning. If we can show that certain premises are true, they combine in a certain way according to our observed patterns that we've seen, observed patterns of logic, and then produce truths about other facts. And so that's what I would want. That's what I would ask you to and that's what I would love to dive into. But as Ben said, we have limited time here today. But if you want to talk about how can we show that mathematics or science or even nature or in general is prescriptive, that's when you can. If you can't show that, then you're not at a point where you can say, well, there must be something making it. Does that make sense?
Okay. Yes.
Okay. Yeah. So I will look forward to talking to you again at some point on that.
Wait, just before you go, you've read Kant, right? And his categories of knowledge and Critique of Pure Reason, right?
Not if I've read it, it hasn't been recently, and so I'm not. But if you want to give me a little bit of homework, I'd be happy to.
Yeah. Could you read Kant's Critique of Pure Reason, because he basically gives what you're asking for, but I'll do my own homework and I'll come with a solid argument.
All right, that's fair. It's a deal.
All right, thank you so much, Donald. I wish we had more time, but thank you so much, and I hope you have a great rest of your Sunday.
Okay. You too.
All right, I'm so excited. We had a math question. That's so awesome. Awesome. Bring
know,
it
that was
on. Bring
great.
it on.